Right now, today, you are paying an average of $740. There's a $300 solution that the air conditioning industry has spent decades making sure you never find out about. A solution your own government published the complete blueprint for in 1947, then quietly erased from every building guide written after 1960. I am going to show you exactly what it is, how it works, and how any family in a suburban home can build it in a single weekend. Because the physics behind this is genuinely strange in the best possible way. 4 feet below the surface of any yard anywhere in the world, the soil holds a nearly constant temperature of around 55 degrees Fahrenheit, roughly 13 degrees Celsius. It holds this temperature in July when the surface hits 105 degrees. It holds this temperature in January when the surface drops to -20. Scientists have been measuring this continuously on real homes across 3 continents for more than 50 years, and it never changes. The soil at 4 feet depth is always 55 degrees. Always. Now think about what that means for a family sweltering in a 95-degree suburban home, paying $200 a month in electricity bills just to stay comfortable. Right beneath their yard, literally 4 feet under the grass, there is a permanent 55-degree environment and never turns off. The technology that captures this is called an earth tube system. You bury a pipe 4 feet underground. You run one end into your home through your existing ventilation return. The other end opens above ground with a screened intake cap, a small inline fan using the same electricity as a single light bulb, pushes outside air through the buried pipe. By the time that air travels 40 feet through 55-degree soil, it exits into your home at around 59 degrees Fahrenheit. That is a 30 to 35 degree drop in air temperature with zero compressor, zero refrigerant, and zero electricity beyond one small fan. This is not a theory. This is not experimental. Research sites running these systems continuously for 8 years across multiple climates measured this exact result every single summer. The soil held every time. Now here is the physics that makes this permanent and not just temporary. The soil is not just a cold battery. It is a 6-month time machine. The temperature wave from summer heat takes months to penetrate 4 feet of soil. By the time July's heat actually reaches the pipe, it is already October and the surface has cooled back down. Which means winter cools the soil that cools your July. Summer warms the soil that will warm your January if you reverse the system. And, unlike every mechanical system you have ever owned, the earth tube system does not degrade. In its first summer, it runs at one level of efficiency. By the second summer, the soil has adjusted slightly around the pipe and the system runs 8% more efficiently. By the third summer, it hits its peak and holds that ceiling for the entire life of the pipe, which is measured in decades. Every compressor and AC unit you have ever owned started dying the day you turned it on. A buried pipe gets better. So why has nobody told you about this? Because in 1947, the United States Department of Agriculture published a complete blueprint for exactly this system, document number 1918 titled Ventilation of Farm Buildings. And then between 1950 and 1970, natural gas infrastructure expanded massively across America. Gas furnaces became the default. Forced air central cooling followed. The underground earth tube, which required no utility connection and no ongoing payment to anyone, had none of those things. It simply disappeared from every building manual written after 1960. Not because it stopped working, because there was no money in telling you about it. The complete material cost for a working earth tube system for a suburban home is under $300. 40 feet of 8-inch smooth-bore PVC pipe costs between $60 and $90 at any hardware store. A screened intake cap is $12. The inline duct fan is $40 and uses roughly the same electricity as a single light bulb. A simple drain trap is $8. Pipe couplings and primer bring the total under $250 in materials. The only labor required is renting a walk behind trencher for half a day at around $120, which cuts a 40-foot trench 4 feet deep in about 2 hours. Drop the pipe in with a consistent downward slope toward the intake end. Connect the indoor end to your existing cold air return duct. Install the fan. Cap the outdoor intake. Backfill. 1 weekend. 1 competent person. No trade background required. Now, the only objection worth addressing is condensation. When warm, humid outside air enters a cool, buried pipe water vapor can condense on the interior walls. The solution is 2 things: a continuous downward slope from house to intake with no low points anywhere, and a drainage point at the outdoor intake end. Once those 2 things are correct, any condensate runs out of the pipe before it can accumulate. A 5-year continuous study on properly drained earth tube systems showed microbiological activity at pipe outlets statistically identical to outdoor ambient air. The systems were clean and the science is settled. If you own a suburban home with a yard, this is the most financially impactful zero-depend project you can build this year. Subscribe right now, because next week we are covering how to grow a full month of food on your apartment balcony with zero farming experience. See you then.